Okay, everyone. Good morning, good afternoon, good evening, and in between. So welcome to the first Systems Thinking Summit. And now we're gonna have the introduction video by Joseph.
Hello, it's my pleasure to introduce and welcome you to the first Systems Thinking Summit. I'm Joseph Casa. A few dot points before we start. If the link drops out, for whatever reason, wait a moment and reconnect. There are three assumptions. Firstly, you've watched the introduction and the overview videos, so you understand the architecture of the website. You've read the About page, and so you know why we've introduced the summit. And you've watched the BCS presentation on two major misconceptions of systems thinking exposed. That's in session 0 to get a feel for how the synchronous, asynchronous communications work. This summit combines the best of asynchronous and synchronous interactions. And if you're just meeting this term for the first time, I'll explain it in a moment. Because the sessions don't actually end after the hour, as they do in a typical meeting, conference, or what have you. The discussion continues asynchronously, or as some people say, offline. And the summit is built on lessons learned in 20 years of experience in international online teaching and conference presentations. For example, one of the early beginnings was an asynchronous conference. It was an experimental web-based conference that my students at University of Maryland University College did in 1998. There were no real-time interactions, and it was created as a final student project in the Master of Software Engineering program at UMUC. And it worked. Synchronous means everything at the same time. And in this particular summit, because there are limited times for discussion and some people like to talk, we're going to put a time limit on how long it takes for somebody to ask a question or make a comment. Remember, the moderator has a mute button. Asynchronous, on the other hand, means it happens at different times, and it's at least 20-year-old technology, as I mentioned earlier. University of Maryland University College was teaching online using asynchronous technology back in the 1990s. How they work? Well, in a typical classroom lecture or conference presentation, you have a lecture, and then a question will be posed either by the instructor, presenter, or by the audience, students, or what have you. There'll be a discussion, and then it will be summarized, and then the discussion or lecture will continue. In an asynchronous mode, when the first question is asked, it spins off a separate discussion, and then there's a summary. And that takes place asynchronously, and 20 years ago in my classroom, it took place in a bulletin board. And here's an example of my class back in 1998 or 1999, I forget which. There was a lecture. I posted the questions in the section of the website associated with that class, and I could see how many responses there were to each of the questions. So moving on, I'll take a few questions and comments, not now, in the chat please. We'll deal with them synchronously at the end of the session, and depending on the circumstances, they may be voice interactive, or we might ask you to type them. If they're voice interactive, the moderator has a mute button because some people like to talk and we want a dialogue. Asynchronous after the session for anything in the chat that didn't get answered in the live session, or anything else you want to add after the summit is over and you've had time to think. So you post it in the session below the video. And don't forget to evaluate the session. And in case you haven't realized it, the asynchronous discussion is just like a discussion on Discord, Facebook, LinkedIn, and so on. And there'll be a 4 to 5 minute break between the sessions, and there will be no long speaker introductions. You came here to listen to the speaker, not the session chair introducing the speakers. The speaker biographical and other information are available on their website. The rest of this session is now going to be 2 points of view: systems thinking, a perspective from Bruce Lerner, and solving the problem of teaching how to apply systems thinking. The discussion will be, as I said, either synchronous or asynchronous. So I'll hand you back to the moderator. See you in a moment.
Thank you, Joey. And now we're gonna head to Bruce.
Good morning, good afternoon, or good evening. I'm Bruce Lerner, and I'd like to provide some observations. I'll start with some background to indicate how I got here. I don't have the history of academic research that Joe brings to the conversation. My history has me practicing systems engineering since 1993. I came from the software discipline with a BS in computer engineering. I worked up the chain from wondering where the software requirements came from, to software digital modules, to electrical mechanical subsystems, then overall systems analysis and design. While performing the role of systems engineer, I have been uncomfortable with the variable, self-defined scope claimed for the discipline. Other than reference to consolidation of practices following World War II and vague references to work at Bell Labs, I was not exposed to the history of systems engineering in any formal training or through INCOSE. While there was talk of systems thinking, there was no indication that a detailed description or definition existed, or that it had roots in natural systems. While I was unaware of the separate history of the evolution of thought about systems during the 20th century and systems thinking, I had one disconnected touchpoint in the work of Charles Kepner and Benjamin Trago on rational management, which was an application of systematic thinking as applied to organizations. I met Joe in a systems engineering setting through INCOSE System Exchange cafes. Joe introduced me to the relation between general systems theory and systems engineering and his questioning of systems engineering's derision of reductionism. You can take a look at the presentation we did for the British Computer Society last April. My dive into general systems theory and systems thinking revealed a wealth of resources to build my perspective, including Joe's work. Fortunately, a reasonable amount of these materials is video, talks, interviews, and lectures, which actually makes the topic vibrant. They also drive home the maturity of thought about systems thinking that existed in the last century. To provide a little of the historical perspective as I understand it, and we'll have a few days for you to educate me if I am misinformed, here's a one-slide summary. General systems theory emerged as we transitioned from mechanistic thinking to a holistic view during the first half of the 20th century. GST was proposed in the 1920s in regard to biological systems by Ludwig von Bertalanffy and developed through the 30s and 40s, with the first English publication in 1950 in his book An Outline of General Systems Theory. The conceptual basis for both general systems theory and systems thinking was for the analysis of natural systems and social systems before its use for engineered systems. While the words system and thinking sometimes were used in series, it wasn't until the second half of the 20th century that they became a couple, possibly promoted by the systems dynamic group at MIT Sloan. In Russell Ackoff's 1979 paper, The Future of Operations Research is Past, systems thinking is scattered about like common knowledge. Ackoff's 1993 lecture, From Mechanistic to Systemic Thinking, highlights that those working in systems theory were well aware of its history. By 1994, Jay Forrester of MIT Sloan offered in his paper, System Dynamics, Systems Thinking, and Soft OR, quote, systems thinking is coming to mean little more than thinking about systems, talking about systems, and acknowledging that systems are important. In other words, system thinking implies a rather general and superficial awareness of systems. He goes on for a few sentences then. The term is being adopted by consultants in the organization and motivation fields who have no background in a rigorous systems discipline. So while the terms were being used in a very general sense, that's how the term systems thinking was introduced to the public. In summary, my current understanding is Systems thinking is a term that highlights that interactions are responsible for the interesting behaviors that are observable in the natural world. The term evolved to express the consolidation of philosophic and practical application of various thinking processes and filters that were used to make sense of our world. My takeaway is that rather than expressing a rigid process for addressing problems to be solved, it indicates a perspective in encompassing process and tools to be applied in analyzing both existing and proposed behaviors of interest. It offers a toolbox of methods which can be applied in various combinations to reveal truths about the world. It is a way of analyzing situations, not synthesizing solutions, and therefore has its origins in science rather than engineering. As engineering applies knowledge revealed by science to impact our world, there is a strong connection between systems thinking, systems science, and systems engineering, but they address separate concerns. I will be listening to the coming sessions to bolster or adjust these hypotheses and expand my understanding of the toolbox. I've captured the references from the slides, and they will be available with the presentation. I hope over the next few days you will share your insights through questions and discussions during the Q&As and in chat. Thank you for coming, and in advance for participating.
Thank you, Bruce. That was interesting. Now, let's take Joe's point of view about that.
Well, you know, Bruce, I've been where you are. I've been in your shoes. And let me explain. Let me tell you a story. In 2007, I was at Cranfield University in the UK. I'd won a grant to develop an innovative course in systems engineering that would include systems thinking. So part of the needs were to teach what systems thinking is and to teach how to use systems thinking to remedy complex problems in the systems engineering environment. And as I read the literature, it was totally confusing. And let me explain. Here's some examples. Systems thinking is a way of thinking. You'll know it when you see it. Well, that's what I had been saying when I was in the University of South Australia in Adelaide. I would teach the importance of systems thinking, the benefits of systems thinking, and then I had to say, well, after about 20 years or so, you'll know it because you'll do it, or you'll know it when you'll see it. But I couldn't actually bridge that gap of how do I teach the students how to do it. Here's another one. When you're considering something in its totality, along with its characteristics as well as its interaction with its environment, and considering its parts along with the interactions between the parts, then you're thinking systemically. Okay, that sounds very useful, but there's a new word there, systemically. And then I found this one a couple of years later, and I love it. Approach to a system with love, understand it holistically and heuristically. Would anybody care to write in the chat how I can teach that? I would really love to hear that. So let's take a look in history and see where did systems thinking come from. Maybe that will help us. So it appears to come out of von Bertalanffy's general systems theory, as you pointed out, and he showed that concepts of reductionism were helpless in appreciating dynamics of organisms. The next mention seems to be in an article by Rasakov, who talked of systems thinking as a three-step process. A thing to be understood is conceptualized as a part of one or more larger wholes, not as a whole to be taken apart. An understanding of the larger containing system is sought, and the system to be understood is explained in terms of its role or function in the containing system. Well, that's fine, but I'm not sure how that would help me when my car doesn't start in the morning. Understanding how the car gets me around to various places doesn't help me start the car. next thing that came up was Wes Churchman's The Systems Approach. He thinks about ideas from 3 standard views in order to understand the system. So he thinks about the purpose and the function first, and then he thinks about the physical structure. Well, that's useful. I can now use 3 perspectives to understand the system. In 1990, Peter Senge wrote The Fifth Discipline, but basically his book is How to Draw a Causal Loop and the Benefits thereof. But causal loops isn't systems thinking, it's just relationships. System dynamics came up from Jay Forrester in 1992. I saw a draft of a paper that was later published in 1994. System dynamics is a focus on the interaction between the parts to build a model. So we're using those causal loops to derive equations to build a model. Okay, that's useful. Causal loops, stocks and flows, and so on. But he also wrote, systems thinking has no clear definition or usage. Uh-oh, how do I teach that? And systems thinking is coming to mean little more than thinking about systems, talking about systems, and acknowledging that systems are important. Well, that may be true of an awful lot of people, but there are people who seem to be using it because otherwise it would have died a death in the 30 years between GST and 1992. And then I stumbled across Barry Richmond's 7 Streams of Systems Thinking. He came up with 7 standardized views in ordered and random order. So about 2007, the situation was there were many different definitions of systems thinking, almost as many as those of systems engineering. It was difficult to learn. It was definitely difficult to teach. But I could take all those definitions and aggregate them into 3 schools of thought. Systemic thinking, which people said you need to think about the system. Systematic thinking, which is thinking about the process. And I found one person who said you need to think both systemic and systematically. Some of the definition also included critical thinking, and some didn't. So in 2007, I came up with 2 hypotheses. Looking for the source of each definition, I thought it was similar to what Lewis Carroll wrote in Alice Through the Looking Glass. When I use a word, Humpty Dumpty said in a rather scornful tone, it means just what I choose it to mean, neither more nor less. Okay, everybody's doing that. And the second hypothesis is the parable of the blind man feeling an elephant. Each definition was a partial perspective of an unknown whole. Perhaps that unknown whole is some combination of systemic and systematic thinking, including all critical thinking or not. Don't know yet, have to work that out. So in 2007, when I was at Cranfield working under a grant from the Levium Trust, Tim Mackley and I came up with the system thinking perspectives. It provided 9 standardized views. It covered the purpose, the functional, the physical, and more. So it provides multiple perspectives. And it also provides anchor point to be on the same page. I noticed people were talking about systems, and every time they came in and said, wait a minute, let's make sure we're on the same page. So each of these perspectives is a page. And so when we look at this from the temporal perspective, for example, we're on the temporal perspective page. And when coupled with active brainstorming, which I'll talk about in the next session, it allowed me to develop my course in Cranfield and then later to update it over my years at the National University of Singapore. And it goes beyond systems thinking, so we renamed it as the Holistic Thinking Perspectives. I continued work on that, not being satisfied because I was using systems thinking, and I realized that there were some problems that systems thinking could not deal with. For example, why your car doesn't start in the morning. And then Bruce and I came up with the updated systems approach with help from Raed and published that earlier this year in the BCS Computer Society webinar, and that's in session 0. The updated systems approach uses an iterative, systemic, and systematic process, understanding the undesirable situation and the conceptual solutions from internal and external perspectives, and then realizing those solutions in a systemic manner. I continued to look at systems thinking and grew more and more and more confused. I found this definition: systems thinking is a holistic way to investigate factors and interactions that could contribute to a possible outcome, a mindset more than a prescribed practice. Systems thinking provides an understanding of how individuals can work together in different types of teams, and through that understanding create the best possible process to accomplish just about anything. Okay, how do you teach that? This is from Dr. Marie Morganelli at SNHU. I found something from the INCOSE International Workshop, published in 2021. What is systems thinking? An approach to understanding a system by examining the interactions among its components and between the system and the external environment. Between the system and the external requirement, that comes from INCOSE. I can understand that, but I can understand examining the interactions amongst components. Those are the emergent properties, but don't we need to understand the components as well? And then we get essential to proper systems engineering, provides framework for understanding and influencing the system's behavior. Okay. And then we get design of reliable systems relies on applying the rules of systems thinking. Oh, rules of systems thinking? What are they? I haven't found them anywhere. And then lately I found this one from Diane M. Fisher in the context of infusing systems thinking activities in pre-college education. She quoted Arnold and Wade, who defined systems thinking as a set of synergistic analytical skills used to improve the capability of identifying and understanding systems, predicting their behaviors, and devising modifications to them in order to produce desired effects. These skills work together as a system. How about this one? Systems thinking has been an academic school of thought used in engineering, policy making, and more recently adapted by business to ensure their products and services are considering the systems that they operate. It's more benefits. It's not what it is. So what are the characteristics of system thinking? Okay, maybe this is useful. Holistic thinking is a key characteristic of systems thinking. Consider the whole over the parts, study the patterns of behavior that you might see, and think holistically about your project to ensure you're making the best decisions that you can. Consider all possible stakeholders who might have insight or who might be affected positively or negatively by your proposed change. Another key characteristic is the willingness to ask the right questions. Starting by naming the problem, considering the factors. Throughout the inquiry, be disciplined, repeating a willingness to ask the right questions and consider all possible answers. I like that, considering all possible answers. How much time do you have to deal with a problem? There may be an infinitely large number of possible answers, some of which are feasible and some of which are not. Take time to experiment to find the answers rather than guess at the answers. I'll agree to that. But if I ask my students a question on an exam and I say, what are the characteristics of systems thinking? I want a reply that says characteristics of systems thinking are 1, 2, 3, 4. Not holistic thinking is a key characteristic and another key characteristic. And wait a minute, where did holistic thinking come from? Not happy with this. Why is it important to be a systems thinker? The world is complex, so our thinking should be complex as well. This person may not have heard of Miller's rule. The human brain can only handle 7 plus or minus 2 objects at a time. So no wonder people who try to handle more are having problems with complexity. If you just try to fix a problem by focusing on the part that needs fixing and not considering how the part got broken in the first place or how the fix may impact others, you risk either getting a new problem or you get the same problem again later. Definitely, I'll agree with that. I then, last week, did a search on types of thinking, and I wanted to see where systems thinking came out. I went to my favorite search engine, dogpile.com, and typed in types of thinking and got 3 hits. I looked at the responses and I saved the web pages. I copied out the different types of thinking. I put them into a spreadsheet. I sorted them alphabetically, and the result came out like this. And you can see that systems thinking is all the way down there. Now, we've talked about the importance of systems thinking. And so where do you think systems thinking would fit in those 15 types? In the top 5, the middle 5, or the lower 5? Would you type your answer into the chat, please? And the answer is none of them. I looked at Titania Asman's 7 most common types of thinking. Where do you think systems thinking showed up in her list? In the top half or in the bottom half? Type your answer into the chat, please. Where it showed up was neither half. Didn't show up at all. And what about Anthony Mativi? His 7 main types, top half or bottom half? Where do you think it fit? Put your answer in the chat. Come on. And where it actually showed up, didn't. But what you can see is convergent thinking, creative thinking, and critical thinking showed up in all 3 of them. Analytical thinking showed up in 2 of them. And then I went and asked ChatGPT, tell me the types of thinking. And it came up with all these. Finally, I got systems thinking. And what ChatGPT called analytic synthetic thinking is what systems engineers call analysis, which is taking something apart, and synthesis, which is putting it back together again. So why do you think that systems thinking didn't show up in the top type of thinking when clearly there's a whole industry out there saying systems thinking is important? In conclusion, Bruce, the literature is still confusing, which is one of the reasons I wanted to hold this summit. And the way to deal with it is to dissolve the problem, and that's why we introduced the systems approach. I'll now turn the session back to Raed to moderate questions or comments synchronously as long as we have time, then asynchronously in the session posting page. Thank you very much for listening.
Thank you. That was quite interesting. So, how would you like to do that? Should we just, like, if we have question or discussion, to raise hands, and depends on people who want to talk, we can, you know, like, limit it to 2 minutes or more, depends on the interactions.
Raise hands.
Okay, I'll stop sharing so we can see each other.
I think everybody went to sleep. We had some questions in the chat.
I'm trying to locate them. About storytelling. Do you have any comments about that, Joe?
Yes.
Or Ruth?
Storytelling is very useful. Storytelling is, I think, case studies. The story's a case. You tell a story, and then you discuss the learning points that need to come out of it.
Bruce?
Yeah, I did answer some in the chat. I think that storytelling is a useful technique for sharing understanding about topics. It doesn't really get you to a point, though, where you characterize something formally enough to engineer on top of it. And essentially what people do is engineer most of the time to make things do what they want them to do, whether it be physical devices or just situations. So again, it's a good mechanism for description, but not for actual problem solving.
Good. And I think Joe have a raising hand. Go ahead, please.
And actually, I completely agree with that analysis. It's actually one of my fundamental problems with most MBA programs, which are use case driven and rarely account for foundational principles. And I say that with my wife having been a graduate of a top-rated MBA program. But so I did say there stories, but it's hard, and then I supplemented with the formal approach because it's not quite adequate.
Right.
Thank you.
Yeah. I think it's important to recognize what it's good for and understand how to make the transition to the next piece that we need to be able to use. So I agree.
I think it would also make sense if the stories were structured in some way, so you could find the information easily. Generally, all the stories, I've got to dig through them to find the information that I'm looking for.
To some extent, stories are generated for particular audiences, and that may or may not be you at any particular point in time. So for particular uses, there may be a reason why we have some kind of story structuring.
I'll agree to that.
Thank you. I think we have Fadl.
Yeah, hi. I just wanted to make an observation about this storytelling. It probably depends on what our purpose is. We've talked about engineering. I'm an engineer. I always think about engineering stuff and solving problems. But I guess when we're thinking about systems thinking, whether something's even a problem, maybe it's a situation, and maybe we don't have to solve the problem. Maybe it's a situation that we want to understand. Maybe it's something we want to explore. So I guess storytelling can be about making meaning and actually sense making in a sense, rather than necessarily just having a target of engineering something or solving a problem. This is probably a bit out of engineering, which is sort of my bread and butter. But yeah, I just wanted to mention that.
Thank you.
So there are a couple of interesting comments coming up in the chat.
I think
the
Carrie,
first one, I think
Carrie is there, having her hand. Yeah, Carrie, please.
Thank you. I agree with the last person that spoke. Storytelling is a great way to get the audience on board. It gives them an example, and it's not. Storytelling has a technique to it and a format, and it's quite hard to do to get something that you might blurb on for 4 pages down to like a half a page to a page and hit the key points. Once you've got their imagination and they're starting to think, oh, I kind of think where you're going, that's when you introduce, things about relationships, directions, perspectives, the dynamics, holistic, heuristics, all sorts of things at that point, and it builds on that, and then you relate that back. And that works whether you're talking to engineers or non-engineers, because at the end of the day, when you do a really good systems thinking workshop, you better not be all in the same discipline.
Thank you.
We have some comments in the chat, but they won't show up in the recordings. So would people who are writing things in the chat like to speak them?
I think Bruce picked up a couple of comments or questions. He was going to mention them.
Yeah, well, so there's one interesting here from Tanuja, I believe. Apologize for any pronunciations I missed as we go along. But there was a question, why are we waiting for the definition? We should look at natural phenomena and try to understand it, and the definitions will follow. I'd have to say from the reading that I've been doing, that's pretty much exactly how GST happened. And a lot of the work that was done in the 50s and 60s which was recognized in the 70s, 80s, and 90s by the system dynamicists and that group of people, really were driven by that. I'm just wondering why in some of the other disciplines we've ignored the fact that a lot of intellectual energy has already covered that ground. Because it doesn't appear to me, I think a little further on, someone made a comment about having separate definitions for separate disciplines. Maybe that was Clement. And I can see something being applied in their own way in different disciplines, but I don't know that it's necessary for them to literally have different definitions. So I'd be interested in understanding or hearing at least what other people think about that.
Bruce, part of that comment in the chat also is, for example, we know that systems have properties that its parts do not, that is not explainable by reductionism. Stop right there, because that is a misconception. If you watch session 0, you'll find out why. Consensus by definition is a perennial philosophical problem. The trouble is, consensus by definition doesn't necessarily mean the consensus is correct or useful. I've seen many discussion groups which are the ignorant leading the ignorant, and they come to conclusions that are ludicrous. And that was one of the reasons I wanted to put this summit together, to point out some of these. One of the participants said she didn't realize there were all these different definitions of systems thinking. Well, if you're only in one area, you find one definition and you work with it and it works for you. I had the same problem with systems engineering. I was working in the NASA environment and I knew what systems engineering was. Then I moved to academia and started to teach it, and I read the textbooks and I said, wait a minute, this is not the systems engineering I know. What's going on? So 20 years earlier, I had the same problem with systems engineering that I later had with systems thinking. Gene, you made a comment in there that you loved it. Why?
It's what I wrestled with for years and finally found a way around it. And stick around until 9 o'clock and I'll let you know.
I'll stick around. Paul Newton made a comment about the ilk of systems thinking derived from the field of system dynamics deals not with all problems, but rather only with problems that develop over time. Is that true?
That's true of the ilk of systems thinking that comes from system dynamics. I think it's true in that case. Yes.
But does system dynamics deal with over time, or does it look at what's going on as in the sense of a causal loop, but the whole process of going around the loop takes time? That's
correct. So yeah, system dynamics only deals with problems that take place through time. And the only difference I think between system dynamics and systems thinking is that when we're doing system dynamics, we're adding computer simulation as a tool to help us think better about systems. When we're doing systems thinking, we're not using computer simulation to do that. We're doing it using our heads. So that's my conception.
Well, there was a conference going on for 3 days earlier this week on systems thinking, and it started 10:30 in the evening for me, so I only watched a bit of the first presentation. And the person there was modeling flocks of birds and things. So some people in systems thinking are using models as well.
They actually weren't. I went to the same conference. I attended the whole thing. It's the one from Cornell. And they were talking about agent-based modeling, and they simplified that to something they call the agent-based approach. So they really weren't. They were talking some about agent-based models. Now, virtually all agent-based models also have feedback loops in them, so you can model using feedback loops using agent systems as well, or agent-based modeling as well. But again, I tend to. Barry Richmond, who was quoted earlier in one of the talks, his definition was a little different. He said that systems thinking encompasses system dynamics and does involve simulation. So they're even within the system dynamics / systems thinking community, there are different ideas about these definitions. But I was just putting in the chat what after 20 years of playing with this has come to be meaningful for me. So,
yeah, but as I said, it's like the parable of the blind man fueling the elephant. There's this thing there, and different people are feeling different parts of it and using those different parts of it to solve their problems.
yeah, yeah. For the I was in an aerospace company for a long time. I just recently retired, and this was always a struggle talking about. There seems to be some focus here on systems engineering as well, but there was always, on the one hand, I have the sense that systems thinking and system dynamics should be part of systems engineering and operations research. On the other hand, it seems that there typically, quite often, there are very little dynamics involved in a lot of the systems engineering work that goes on. There is, of course, in operations research. So this is a hard thing to come down to a universal definition of systems thinking, I believe. And that the Cornell folks have developed their own definition that the conference you were talking about, that's quite different. They talk about something called DSRP, differentiation, system, relationships, and perspectives. So they have. It's very interesting what they're doing. I'm just now absorbing that. So that's rather new to me.
Well, I've noticed that it seems that there are people out there that are trying to make it more complex and more complicated.
Yeah.
And I've taken the other approach.
Yeah, I agree with you.
And that's what I'll talk about in the next session.
I also, as I've been trying to come up to speed here, find that in some ways systems thinking is more of the philosophical underpinning of a number of these other systems, this kind of things, whether it be dynamics or operations research or engineering. And I think there's a core basis that all of them draw from, and they're trying to address different sets of issues, which is why they have a specific set of parameters that they use to essentially evaluate the world for solving the kinds of problems that they're built to solve. So I actually would not be surprised if there was not a good underlying description of what systems thinking is, and systems thinking then is one of the underlying premises that the other disciplines work from.
Well, what we showed in session 0 was systems thinking is a problem-solving tool for a particular class of problems, but it's not the only problem-solving tool.
I'm not even sure that it's a problem-solving tool. I think it may be an analysis tool, but problem-solving is more on the synthesis side than the analysis evaluation side.
Well, I think of problem-solving as the entire process of understanding the situation, defining the problem, and then going through and conceptualizing a solution and realizing.
We can't always work our way up to a definition that's broad enough that it covers everything.
So systems thinking is used in the front end. System dynamics, as Paul pointed out, is used in the front end. and it should be used in the front end of systems engineering as well as OR. Years ago, I found a definition that differentiated systems engineering from operations research. Operations research deals with systems in being, whereas systems engineering creates new systems. But what they're doing is pretty much the same. It's just the context in which they're working.
Right. Mm-hmm.
I think there is sorry, carry on.
Neither of them read each other's literature.
I think.
No, I'm seeing a contradiction in terms in the chat. Chaos engineering doesn't sound like something that can really exist to me. Anyone else have a question about that? Is that the attempt to make chaos or the attempt to manage chaos?
Would you quote the chat so we know what you're talking about?
As it says, would you all say that systems thinking is a foundational core for the application of chaos engineering? If so, how? I'm totally new to this group and appreciate you all having me. Well, hello, Ernesto. Those two words together seem very strange to me, however.
He says making it.
Well, from my research into looking at what people think systems engineering is, they're creating chaos.
And there's a question: can you engineer chaos? And I guess you have to be able to define what chaos is, I guess, if you're going to try to engineer it, or at least more desirable. It doesn't necessarily have to be better.
The definite chaos is a type of dynamics that does not repeat.
If you want, I can help you out a little. As I understand it, chaos engineering is more or less engineering in a dynamic and changing environment. Think about the agile process and other things where you're not starting from fixed requirements and doing a waterfall process, but instead, you're managing a very complex thing. So I would say yes to Ernesto. It would really help to understand, the ideas of systems like feedback and causal loops and that sort of thing. So.
Thank you.
Thank you.
I love that background.
So I think we have 5 more minutes. Trying to go through. I think Clement mentioned something about the idea of thinking points to the cognitive processing power of the human brain. All the various forms of thinking are largely cognitive processes. What separates systems thinking from the rest? That's from Clement.
Actually, when I started reading chaos theory years ago, I was sort of wondering whether it was made up, because back in the early days of computers, we couldn't represent numbers to a large degree of precision. And so there was something that was called round-off error. So if you started a process going and you let it run for a long time, it would generate one set of numbers. But if you stopped the process, saved the numbers, and then restarted the process again later with the saved numbers, you'd get a different result, because you dropped off the digits that were not savable in the precision, if I explain that correctly. And so I wondered if the whole chaos thing is just made up, and it's supposition upon supposition with its feet firmly based in midair.
There's really recently just been a solution to a problem of non-repetitive tiling, evidently, which sounds like it fits the definition of chaos.
Somebody said chaos in the chat. Chaos engineering was invented by Ahihara.
Ihara is the way I think. He's Japanese, and it sounds like it's related to the computational problem that was discussed just previously.
Okay.
Any last questions or comments before we go to the break? Thank you, Ernesto.
If I can just comment, because it's come up a couple times about the different terms across different languages. Josiah Macy Foundation sponsored what turned out to be 12 Macy conferences, which started by the cyberneticians. And Bertalanffy was considered first a biologist, but then he put himself in the cybernetician camp. They were only 12 because the different disciplines couldn't speak to each other, and there became such animosity they couldn't agree on the next meeting. And it started with cyberneticians who themselves started fighting internally, Wiener and McCullough and Pitts, but also Margaret Mead and Bateson were also part of the crowd. And so you ended up with a wide variety of disciplines, and they just could not speak to each other because they couldn't understand each other's meanings. I happen to have Rosenbluth's personal copy of a number of the volumes. His library got disposed of, obviously, at some point.
Now,
Arturo Rosenbluth.
If you're a religious person and you think in terms of use systems thinking to think in terms of similarities, I wonder if we're suffering from the Tower of Babel syndrome.
Well, it would account for the schisms that we've seen repeatedly over the years.
Everybody's using different terminology, but for the same concept.
And then, of course, we can ask, what do we want to achieve by the whole discussion?
Enlightenment. Okay, right.
I think maybe we can break now for like 5 minutes break and come back for the next session if you want to have a cup of tea, coffee, or a beer, depends where you are.
Okay, see you in 10 minutes.